Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. When discussing how devices interact on a network, the topic of architecture plays a central role. Network architecture refers to the structure that defines how systems relate to one another, how roles are assigned, and how communication occurs. It tells us whether devices operate equally or whether some systems serve others. More than just a design preference, architecture dictates the flow of resources, determines control responsibilities, and frames how users and systems exchange data. Understanding the difference between architectural models helps explain why networks behave the way they do. The choice of architecture isn't just theoretical, it influences everything from daily operations to long-term scalability. Different architectures affect how a network is managed, how resources are shared, and how security is enforced. From small workgroups to enterprise environments, the decision between a peer-to-peer or a client-server model determines the strengths, limitations, and potential of the network. For Network Plus candidates, being able to distinguish these models and recognize their characteristics is key to answering questions and understanding real-world deployments. A peer-to-peer architecture is defined by equality between devices. In this model, every node can act as both a client and a server, sharing its resources while consuming others. There is no centralized control, and each computer operates independently. Users may share files, printers, or applications directly without routing requests through a dedicated service host. This model emphasizes simplicity and decentralization, reducing the need for specialized hardware or complex configurations. Peer-to-peer networks are known for their ease of setup and minimal infrastructure requirements. They work well in small environments, such as home offices or small classrooms, where only a few users need to share files or print documents. Each device is configured independently, which simplifies deployment but limits centralized control. Because there is no overarching management system, each user is responsible for their own access settings, which can lead to inconsistency or security gaps in larger or less disciplined environments. In contrast, client-server architecture relies on designated systems to provide services and other systems to consume them. The server acts as a central resource manager, offering functions like file hosting, application delivery, or authentication. Clients make requests for these services, and the server processes and responds to those requests. This model is widely used in business environments because it supports control, scalability, and secure administration. By centralizing functions, client-server networks become easier to monitor and maintain. Client-level models offer several advantages that make them attractive for structured deployments. Management is centralized, which means administrators can enforce consistent security policies, schedule updates, and maintain a controlled environment. These networks also scale more effectively, new clients can be added with minimal reconfiguration, and servers can be upgraded or load balanced as needed. Because resources are hosted centrally, data consistency improves, and backup strategies are easier to implement. In a client-server model, the roles of the participants are clearly defined. Clients initiate communication by requesting services, and servers respond by delivering content or access. This separation simplifies task assignment and allows each system to specialize. For example, a dedicated print server manages print jobs, while a web server handles page requests. This clear role distinction helps avoid conflicts, streamline processes, and maintain a secure, organized environment. Authentication and authorization are handled very differently between peer-to-peer and client-server models. In peer-to-peer networks, each user configures their own sharing and permission settings. This often results in inconsistent enforcement and limited auditing capability. In client-server environments, centralized systems control who has access to what, when, and under what conditions. This centralized model supports group policies, role-based access control, and detailed logging, which are essential for compliance and structured auditing. Network traffic also behaves differently depending on architecture. In a peer-to-peer system, communication occurs directly between nodes, resulting in more random and unpredictable traffic patterns. In a client-server setup, traffic is generally directed to and from centralized hosts, which creates more predictable paths. These differences impact bandwidth utilization, with peer-to-peer systems potentially generating more localized congestion, and client-server networks concentrating traffic around key infrastructure points, such as file servers or gateways. Common examples of client-server services include web hosting, where a browser, the client, requests pages from a web server, file servers that manage shared directories for multiple users, DNS servers that resolve domain names, DHCP servers that assign IP addresses, and authentication services like Active Directory that manage user logins. These services are designed with a central server mindset and illustrate how vital the client-server model is to the structure of modern IT environments. In decentralized networks, peer discovery is essential for communication. Without a central authority, devices must find each other through broadcasting or limited directory services. Peer-to-peer operating systems may use built-in features like Windows Network Discovery to list available printers or shared folders. These identification methods lack the structure of DNS or DHCP and can lead to performance issues in larger environments. Peer networks also lack persistent naming systems, making repeated connections less reliable and increasing the manual workload of the user or administrator. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. The management responsibilities in peer-to-peer and client-server architectures differ substantially. In a peer-to-peer environment, each user manages their own system, including local resources and access controls. There is no centralized management tool to oversee or configure multiple machines simultaneously. This approach may be manageable in very small networks, but becomes cumbersome as more users and devices are added. In contrast, client-server architectures typically include centralized management consoles, domain controllers, and group policy frameworks that allow administrators to configure, monitor, and update devices across the entire network from a single location. Security implications are closely tied to the architectural choice. Peer-to-peer networks tend to be more vulnerable because there is no unified security policy. Each device may use different settings for file sharing, password protection, or encryption, resulting in inconsistent protection and increased exposure to threats. In client-server environments, security policies are enforced centrally. Role-based access controls allow only authorized users to access specific services, and servers can enforce password complexity, multi-factor authentication, and activity logging. This centralized enforcement greatly enhances an organization's ability to protect its data and systems. File sharing behavior also differs between the two models. In a peer-to-peer network, users typically share files by enabling sharing on local folders. This method is simple but can lead to unauthorized access if permissions are not configured properly. There's also little version control or tracking. In a client-server network, files are hosted on central file servers, which often include backup procedures, access logging, and version management. Centralized storage supports better collaboration, consistency, and recovery options, especially when multiple users are accessing or editing the same documents. Software behavior and deployment strategies reflect the architectural model in place. In peer-to-peer environments, applications are installed and maintained individually on each device. Updates must be performed manually or through decentralized methods, which can result in inconsistent software versions across systems. Client-server models typically support centralized deployment tools that push updates or software packages to client machines automatically. This ensures uniformity and reduces the administrative burden associated with keeping systems current and secure. Monitoring and logging capabilities are also heavily influenced by architecture. In peer-to-peer networks, logging is minimal and confined to each local system. There is no centralized dashboard to analyze system activity, detect anomalies, or generate audit reports. Client-level networks, on the other hand, often include server-side logging, centralized event viewers, and intrusion detection systems that provide full visibility into what's happening across the environment. These features are essential for compliance, threat detection, and forensic analysis. Scalability is another area where the contrast between architectures becomes clear. Peer-to-peer networks do not scale well because each additional device increases the complexity of managing access, updates, and security. There is also a higher chance of resource conflicts and bandwidth congestion as more devices attempt to share files or services. Client-levered networks are built with scalability in mind. New users can be added by creating accounts, new devices are easily joined to the domain, and services can be distributed or load balanced across multiple servers to accommodate growth. Architecture types frequently appear on the Network Plus exam in both direct and scenario-based questions. You might be presented with a diagram of a small network and asked to identify the model or evaluate its scalability. Other questions may describe characteristics such as decentralized control or centralized user authentication and require you to determine which architecture is being described. Understanding the behavioral patterns, strengths, and limitations of each model helps answer these questions with clarity and precision. In many real-world cases, networks evolve from peer-to-peer to client-server models as they grow. A small office might begin with a few connected computers sharing files directly. As the business grows, the need for centralized storage, stronger security, and simplified management leads to the implementation of servers. Hybrid deployments are also common, where some services are centralized while other tasks are handled locally. Understanding this migration process helps IT professionals plan scalable, maintainable networks and anticipate the tools and configurations needed as demands change. In conclusion, peer-to-peer and client-server architectures represent two fundamentally different approaches to building and managing networks. Peer-to-peer designs offer simplicity and low cost for small, informal setups, while client-server models deliver structure, control, and scalability. By recognizing the advantages and limitations of each, IT professionals can design networks that meet specific requirements while allowing for future growth and adaptation. Mastery of these concepts not only supports exam readiness but also strengthens foundational skills in network architecture planning. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.